Welcome to my course Preventive Maintenance of Diesel Generator Set Part 3. In this Part 3 we are going to discuss the critical alarms of the DG sets and its troubleshooting. This is a very important section. In section 1 we have learned basic introduction and maintenance strategy. In section 2 we have gone through a detailed preventive maintenance procedures of entire DG sets, in which we have covered fuel section, air section, oil section, water section, exhaust, electrical and AMF. Now in this section 3 we will be going through the critical alarms which is coming from different parts of the DG sets, and we will see that by seeing that alarm text or alarm code, how we are going to take the actions and what exact action is expected from the operator. So I request that this would be a very important part of this training, and though it's very a small one, but it is having a lot of importance in the practical application. So let's go on the next screen. In this we are going to discuss two different controllers. One is a CGC 400, which is a DEF controller. Okay, so because I am using DEF controller as well as Semac controller, this two controller is a advanced one which has been used in 20 kVA to 750 kVA of different DG sets on LT side. So, and this control is having a very good logic and options are available that you can configure as per the customer requirements. So we'll be going in detail for CGC 400, which is a DEF controller. Okay, and then in Semac also we'll be quick through the basic parameters and troubleshooting procedures. In section 4 I will take you through the detailed engineering diagram of the controller as well as electrical, AMF and ACDB circuits. So on this screen you can see that we are seeing the DEF controller which is mounted on the AMF panel box. Okay, and this is a single line diagram of this AMF controller. So from the single line diagram we can see this left hand side is a engine and alternator, and in the right hand side is the grid part which is shown in the two circle, which is intersection. Wherever the grid and LED is there, that means that object is active. Here engine is active, alternator is active and the DG breaker is active, whereas on the right hand side we see that grid power is failed, so that is why it is a red indication. So this is a basic thing which one should know about controllers. Whatever the controllers you are using in your industry, but every controller has their basic diagrams and basic information by which you can make out the current status of the DG set. On this display we see that we are getting a value by default value of fuel level, oil pressure, water temperature and DG run hours. So there is a buttons given up arrow and down arrow. By scrolling this you can scroll through the by default parameters which is visible on the display. So critical engine parameters are like what we know is like fuel level, oil pressure and water temperature. This is the most critical parameter of the DG sets. We have done the preventive maintenance, in which also we have divided that fuel system service, oil system service, air system service and cooling service. Why we have taken this 4 different section of preventive maintenance? Because we want this parameters to be in a normal range, and that is why we are doing a preventive maintenance. So it is obvious that we will be always looking for these critical parameters on the engine controller display, and by which we'll verify that whether our machine is working as per requirement or not. So fuel level, oil pressure and water temperature is the key parameter of any engine, whether it's a small engine or a big engine, or whether it's a car or whatever. But these are the very basic things which one should know. Other parameters what you can see on this like phase to neutral voltage, and this is on the alternator side, and then there is a RPM, frequency, DG battery voltage, each phase voltage and current, and all these basic things are also shown in the display. Once we scroll this arrow, we can see those parameters also. If you open the AMF panel, you will find this overview in which there are some switches are there, contactors are there, battery chargers are there, relays are there. So this we will be discussing in our section 4, where I will explain in detail entire power and control wiring diagram. This is a backside view of the controller, and we see that here we are sensing the mains voltage, generator voltage, then generator current. Here we are taking a feedback of the generator breaker and mains breaker. This is our connectivity section, like this 49, 50 and 51 is a RS485, 53, 54 and 55 is a CAN bus, and here some wiring like a auxiliary supply has been given on 1 and 2. Okay, and these are the multifunctional inputs are there, 5, 6, 7, 8, 58 and 59. These are the binary input, which is nothing but a digital inputs. Okay, so these all are we are going to discuss because we have a specific control wiring diagram in which we will discuss that what are the digital inputs, what are the analog inputs, what kind of alarm is coming in which form, how the controller is reading, what signal is controller is giving to us, and accordingly what action will be performed automatically. So this all is a part of this. But why I am showing you here, because this all connections we have seen that in a preventive maintenance we check this connection, we make it tighten properly if it is loose, and we also keep this entire controller properly clean. If you see that it's a purely clean, everything is clean here. So in the preventive maintenance, one should always ensure that there should be no any dust deposition. So if any loose wire is there, definitely you will get a wrong input or no input from the system, and because of that some alarm or tripping might come. So for electrical side, basic tightness of this all connectors is mandatory. There are two types of alarm signals. One is a digital signal and another one is the analog signal. Every controller is having a feasibility on the higher side. If we are buying a good controller, so in that specification sheet we have been given all details, data like what is the auxiliary voltage of the controller, how many digital inputs it can take, what are the analog inputs, how many analog inputs it can take, what is the final output in terms of digital, what is the signal type of signal for analog, whether it is a resistance or it's a 4 to 20 milliampere signal, etc. So all these details are given on the controller, and if we read the controller rating plate or on the back side, normally all these details are available. Now we'll discuss most important part, which is a list of critical alarms which we normally face during our operation. So today we'll see the alarms here. So first one is the engine, in which there is a digital input is coming from the engine side. Okay, so any controller is there, their controller is having a provision of taking a input from digital sensors or switches and from the analog sensors. Normally digital alarm is coming from the switches. Okay, so if we see what alarm it may come, like low level of fuel, low oil pressure, high water temperature. So this is a three basic things which is coming from the digital switch, because we have put a digital sensors in the diesel generator in the engine side. Like in the fuel tank we have put a float, and which will operate at certain amount of fuel level inside the tank. As soon as that float operates, there is a switch there, and that switch will give a command from normally open to normally close, or as per our logic, and that command goes to the controller, and then controller generates the signal on the output relay, and that we can extend up to the our central monitoring system. So this is very important part, like low fuel level, that is coming from the switch. Similarly, there is a LLOP switch, low lubrication oil pressure switch. So if oil pressure is going down at one threshold value, then it triggers that switch automatically, and it gives a command in the form of normally open to normally close. So it gives a, basically it's a PFC contacts through which signal is moving, and we get the continuity on the controller side. And as soon as that command has been given either in a normally open or normally closed form, controller recognize that alarm, and then it further converts into the output side, and it extends the alarm up to the knock, as well as there is an indication and beep sound is coming on the display of the controller. Third one is the high water temperature. So on the top side of the radiator, where there's water is coming from the engine, there is a high water temperature switch is mounted, which is continuously touching the high coolant water, and as soon as temperature goes below 100 above 100 degrees centigrade or so, that switch operates, and we also get a command on the controller sides. So this is basically a switch generated command directly from the equipment, and it is, this alarm is called a digital alarm, because this input is in the form of digital input, like it is either giving normally open as a input or normally close as a input. The next is a engine analog alarms. Here again a low fuel, low oil pressure, and high water temperature. So on the left hand side we have seen these three alarm which is generated from the switch. Now this another same three alarm on the right hand side, which is generated through the analog sensors. So why? Because this is very critical part of the engine, which is the fuel, oil and water. So that is why continuous and monitoring and proper validation is required. There is a possibility that digital switches malfunction or it may not operate. So we are not relying only on the one channel of signal, and that is why we have another channel called analog. So analog also has one sensors which continuously monitors the fuel level. Okay, there is a difference between the digital and analog, because digital is it operates only at the predefined value when it reaches, and it gives a command in the form of normally open to normally close, because it's a kind of switch. So switch either will get open if it was closed earlier, or it will close if it was open earlier. So basically it's a switch. Whereas on the right hand side, this is a basically an analog sensor, which we can call it as a transducer, which converts the signal from one form to another. So normally these analog signals, controller, our job is to make these signals available up to the controller, and controller can read it. So controller, any DG controller reads only a two value in the form of analog. One is either a resistance or a 20 milliampere signal, 4 to 20 milliampere signal. These are the only two input which today's controller can read. So our oil is in the form of liter, our level, because we are measuring basically a quantity or length of the empty tank. Similarly, the pressure is in the form of kg per centimeter square or psi or so. Similarly, high water temperature, that it is in the form of Fahrenheit or degree Celsius. So these all are the different units. So these all unit has to be converted and calibrated in the form of resistance or 20 milliampere signal as per our technology what we have installed at the site. So normally in the industry, in the telecom, like 25 to 100 or 50 kVA or 500 kVA DG set, they are having a basically a resistance signal which converts this any signal into in the form of resistance, and then controller reads the resistance value, and then it gives us a exact value that what is the level of fuel at particular time, at the same time what is the oil pressure and what is the coolant temperature. And in that controller we have to make a nominal value and what is the maximum value and what is the minimum value. So as soon as that value go below threshold or beyond threshold, controller itself generates an LRM and takes an action. So this action has been taken by the controller by reading the analog input from the engine, and here the controller has taken an action based on the digital input received from the engine. So these are the two different type of technology of reading the and generating the alarms. Now let us go on the alternator side. In alternator we can under voltage and over voltage alarms, then under frequency, over frequency alarms, unbalanced voltage alarm, over current, or we may say overload, battery charger faulty, charging alternator faulty, battery low, start failure, crank failure, Hertz/V alarm, which is nothing but a ratio of alternator output voltage and the engine RPM, and then fail to start, fail to stop, and then generator breaker close to fail, open fail, mains breaker close fail, open fail. So these are the basic alarms normally we received. And what is a role of the operator, that as soon as this alarm comes, okay, it trips the engine and person has to take an action, like he has to go to the site and then he has to go to the equipment, he has to acknowledge the alarm, and then once the alarm has been acknowledged, and then he can again check the circuit, and if everything is normal, then he can restart the DG by putting an effort in the manual mode. So this is basically the procedure is. Let's see now one small video in which we will see that if low lubrication oil pressure alarm is there, then how we can acknowledge, because oil pressure, high coolant temperature, low fuel level, these are the critical alarms. So in this condition, engine always goes in a shutdown mode. So unless and until we go to the site, we acknowledge the alarm, we reset it, engine will not start in an automatic condition. So that is why person has to visit in the event of such critical alarm. So here we see that the red LED is glowing on the controller, that means there is an alarm is present. Even indication lamp is also glowing, and this LED is also glowing, we can see on the controller. When person has to press an OK, then only this LED goes off. Even indication lamp is also got reset, and once it is reset, then only we can start the engine in the manual mode from here. So this is what that person has to visit, and he has to acknowledge the alarm by pressing this button. So every controller has a more or less the same kind of process, that how to acknowledge and accept the alarm. But here we are discussing all these things for the DEF controller CGC 400 model. So in this video, in this picture, we can see it's a red LED is glowing on the controller, which is a caution symbol, which saying that there is a low loop oil pressure alarm is there. So it's a very critical alarm, okay, and that's why person has to go there and they have to acknowledge this, and then they can switch off the grid if grid is available. Like here we can see that this grid is there, so we can switch off the grid, and then we put this DG into the manual mode, and then by pressing this green button, we can start the engine in manual mode, and we can see on the display that what is the lube oil pressure is there, and before doing all these we have to thoroughly examine inside the engine. We have to wait that engine should cool down at least 15 to 20 minutes as discussed in our maintenance procedure for the oil service, in which we have clearly said that when person reaches the at the equipment, he has to wait for 15 minutes. If engine is still running, it has to be cooled down. Once engine cools down, then he can take the dipstick out and he can see the oil level inside the in oil tank, and if oil level is sufficient, oil level is there, and there is no any proof of leakages from anywhere else inside the DG set, then only he can acknowledge this alarm and he can make an attempt to start the DG in manual mode, and he will validate that what is exactly the lube oil pressure is coming here. And also in this intelligent controller you will come to know, because we have a two different source of alarm, one is from the digital and other one is from the analog, like we have seen earlier also. So in that we know that there is a two different channels. So here the code will appear on the screen. Okay, here the code will appear, and that code will tell us that whether this is from the digital switch or whether it is from the analog sensor. So here we can see that code number is 3060. So there is a user manual has been given by the every controller manufacturer, and in that user manual we have to look for this 3060, and here there will be a mention that it is from the digital switch, for example. That means whatever the switch is there inside the oil tank, that switch has operated, and because of that this lube oil pressure alarm might have come, or there is some other issue in the relays in the MF panel. So there could be multiple reasons, but at least at the prima facie we can see this code, and based on that we will come to know whether this alarm has been from analog sensor or from the digital switch. So this is the way that person has to always look for the indication which has been provided in the LCD display of the controller, and accordingly the next course of action has to be taken. So here few pictures I am showing here just to give an idea that earlier we see that low lube oil pressure video and the pictures, that was a part of the engine fault. Here we are seeing that there is a under voltage alarm is there. Okay, so under voltage could be from DG side or it could be from grid side. So there is a code number has been given 1170. So by looking at the 1170 in the operation manual of this DEF controller, we can make out that what is whether it is a generator over voltage or a grid over voltage. Here we see that whenever there is an alarm, definitely this caution symbol will glow in the form of red, and here this display is there. Once you make it okay, then this display will go away and this alarm will transport into the history. So before it goes into the history, always note down this code or description as per the controller's logic, and then you can further do the root cause analysis that why this alarm has appeared. So now we understood basic things, that what are the engine related alarms, what are the alternator and other electrical system related alarms, and if this alarm comes, normally what could be the probable reasons that we have to understand. Because if you have completely gone through the section 2, then I would say that you can easily predict that what could be the issue in the diesel generator set if such alarm comes. So it is mandatory that if, before you completely go through this section, section 2 has to be completely covered, so it gives you a fair idea to predict the root cause of the alarm, and you can accordingly take a action for the troubleshooting. So this is the basically a DEF controller chart, in which this is a code number what we call is 4220. Here it is mentioned that it is came from analog sensors, and it text is RMI 6.1. So RMI 6.1 is its technical description is low fuel level alarm and that is from analog sensors. Then if we go in the setting mode, okay, it gives us a set value. So before we do a commissioning, all these standard nominal values we have to feed in inside the controller. So there is a standard file. That standard file is always a signed off document between the service provider and the user, okay, and based on that they put this value and they configure the one file and they upload this file into the controller. So controller is set as per the company's requirement. Controller has normally the factory settings there, but based on our requirement we can make a signed off with our DG provider who is providing us this entire DG set and services, and we can make a decision that this is the final golden parameter settings which has to be implemented into the controller. So this activity is normally being done during a commissioning time. So that time we have to carefully see that this all value has to be there, and then only we can accept this as a properly commissioned engine. So here that value is 10 and the unit is percent. That means at the 10% of the fuel will reach, at that point of time this analog sensor will generate a alarm, because this analog is continuously reading the value from 100% to 0%. But when it reaches at 10% of the total volume of the fuel, that time controller, like a def controller, will take a decision, because once it is reaches a threshold value, it will generate an alarm and it will decide what to do. Now what to do, that also we have to configure during this commissioning, like what is the range here? Range is 0 to 100. What is a second? Like whatever action controller will take once this 10% of value is reached, now action will start, countdown will start. So in a 10-second it will take an action. Now what action it has to take? So this has been given in the fail class. Like one is a block, that means we can block this alarm if we don't want, or we can create a just a warning signal. So DG will still continue to run further, even the fuel will reach to a 9% or 8% of value, but it will generate a warning signal on the controller display, and that display we have to read, and accordingly we can take a decision. So it's up to us that what fail class we have to decide based on our complexity of the operation. So next, third one is the trip GB. So GB is a generator breaker. That means we can run the DG but not on the load. So DG will continuously run on no load condition if we have selected fail class 3. So like DG will not stop, but it will consume a less fuel because now load is not there. Fourth option is trip generator breaker plus stop. That means it will trip the generator breaker and after that it will stop the engine also. So that is normally the desirable condition if we are operating remotely the diesel generator set, and so as soon as we reaches this value we have to see that generator should not further be used, otherwise there will be a tank will be empty and there is a chance that air may come into the circuit and then it create a further additional problems. Now 5 is trip MB. So it can also trip the mains breaker also. Option 6 is trip MB GB. That means it will trip both mains breaker and generator breaker whatever is running. And 7 is complete shutdown. So it will immediately shut down the engines without bypassing the, basically it will bypass the cooling down also, cooling down period which is normally 60 seconds to 300 seconds, depends on the setting parameter. So that also will be bypassed if we select the option 7. So this is how normally we have to configure every alarm into our controller. So whatever the critical and non-critical, major, minor, every alarm has to be configured as per the customer's requirement. So it's a lengthy procedure. So that is why normally we prepare entire Excel sheet of every alarm. We carefully select the set value, their unit, and what is the time we want to trigger this alarm, and what the action we want, and then we upload this entire file into the controller. So all these alarm once in a time it will be uploaded in the master controller, and accordingly controller will take a decision. Similarly, we'll take another example like 7.1. So 7.1 is a low lube oil pressure. This is also coming from analog sensors, and here also similar like 1.5 is the set value, okay, and here the action is in 5 seconds. So as soon as this value reaches, action will be taken in the 5 seconds of time, and this is a very critical alarm. So here the action what we have selected is shutdown. So we cannot run the engine if there is a leakage of oil and there is a low pressure is reported on the controller. That means oil is not sufficient inside the DG set. So this DG set can go into a very high temperature, and the piston, rings, everything can damage, and there is a chance that it can be seized also, it can jam. So that is why on the safer side, as soon as this alarm reports, we have to immediately shut down the engine. So that is why we have selected the fail class number 7. The last one is RMI water 8.1. So as soon as this alarm comes, okay, also we have taken a decision that it should trip. So it will trip all the generator breaker and everything, and then it will stop. So this is also another kind of very fast action, like it will trip all the breakers, whatever, like if generator is running, so that definitely generator breaker is on, so it will trip the generator breaker, so all the load will be isolated, then generator will go into the no load condition, and then it will stop them. So this is how the all fail class has to be decided in a close consultation with the OEM and engineering department. So now we are very much sure that what is the analog sensors, how these analog sensors gives a value. Basically it gives a value in the form of resistor, in the resistance, or in the 20 milliampere signal, and this is read by the controller, and then controller takes an action based on the set value, time second what we have selected, and the fail class what we have mentioned. If we don't want this to take any action, then we can simply make a off here, so then it will not work if we will not enable it. So all these alarm we have enabled here. Now we have seen the analog side of the alarm. Now we'll just go through the digital side. Same 3 alarms, like it's also there on the digital side, like high coolant temperature, low lube oil pressure. So if alarm is coming from both the sensors, let's say, then it is very much sure that there is a real fault inside the engine. So there is no any chance of making any doubt that sensors might be faulty, or there might be some any nuisance tripping or so. So that is why we have put 2 different sensors for this kind of alarms. So here also we can see that what is the time value is there in a 1 second, 10 second, or whatever time we can select as per our requirement, and we can select the fail class also. So this is basically a digital side. So here only controller gets a signal in the form of normally open or normally close. As soon as that command receives, controller takes an action based on this time delay what we have selected and the fail class what we have selected. Here one more example I'm giving you here, the generator under voltage. So if this alarm comes on the generator display, we will get this 1170 as a fault code. That means with that we will come to know that this is a generator under voltage level 1. So there are multiple level is given. So based on our requirement we can select level 1 only, and we don't want further level, then we can also mask them. So here what we have done here, we are putting 90% of our nominal value. So when we do the master configuration inside the controller, we know that what is the nominal value of the generator voltage, which is a 415 volt. So 90% of this 415, once it is reaches at this level, okay, then with this 15 second of time delay, it will wait for 15 seconds, and if up to a 15 second, if generator voltage will not improve and it will remain at 90% or further go below, then with this 15 second, after this 15 second, this master controller, DEF controller will take an action. And what action it will take? It will trip the generator breaker and it will stop the engine, because it is providing the poor voltage. At the poor voltage load side, there is a problem, so we don't want that problem, and that is why we are tripping the generator. So there are list of alarms, and the philosophy of all these alarms is very same. Like, only thing now we have to understand that if generator under voltage is there, so engine is tripped. Now what action is required? Like, we have to again ensure that generator should run and should run in a normal condition. Though what troubleshooting is required, that is a very important part, and that we'll discuss in a upcoming slides. So here also very critical alarm like generator under voltage, mains over voltage, mains under voltage. So these are the standard alarms, because grid side also, as soon as grid is having a poor voltage, master controller sends them and it's generate the output. So every alarm has a unique fault code, and based on that fault code we can decide what is the actual alarm is and what the action we have decided. Here the frequency alarm is also we have mentioned. Here the generator overload protection alarm also. And so these are the supercritical alarms like generator contactor feedback. If it is not available, then also it will shut down the engines. Mains contactor feedback is also not coming, then also it shut down the engines. Then emergency stop push button, if somebody has put the emergency stop push button, then also it will immediately shut down. If there is a high acoustic temperature from the switch, which is a digital alarm, then engine will shut down. Likewise, if coolant temperature is more than our threshold value, which is 100 degree, normally switch operates around 95 to 100 degree centigrade. So if we reach above that value, then also this alarm comes. Sometimes what happens, due to wear and tear and drifting, the switch may not operate exactly at that required. It may operate at 2 degree early, or maybe at 2 degree at delay also. So that's why we are also taking input from the analog. So at least we can have a all the double assurance that we will definitely going to get the alarm in the event of critical faults. Here this is a crank failure alarm. So even the crank fails also, then it gives us a warning. And once a 3 attempt has been given for a 3 attempt, and even after 3 attempt engine does not start, then after completion of this 3 attempt the alarm appears, which is a start failure. That means it has tried to crank 3 times, but engine could not start it. So that's why 4570 code will appear, and we will get the alarm called start failure. So these are the all alarms. Again here Hertz/V by failure. This is also one alarm, like when the alternate engine starts, so alternator builds the voltage in a proportional to the speed increment of the speed of the engine, because there is a ramping up. As soon as the generator starts, it reaching from 0 rpm to 1500 rpm in a 6 to 7 seconds, and even voltage also reaches from 0 volt to 400 volt. So there is a specific ratio of frequency and voltage. So let's say if frequency as rpm is increased but voltage is not developed, which is required to develop accordingly, if that situation comes, then this ratio get disturbed and it trips the engine. So this is also one of the alarm that which gives us an idea that there is no synchronization between the speed and voltage build up, and this is what it indicates. So here we are seeing this all alarm AMF panel, in which we see that all cable connection and everything is made. Now what we will do, we will go with one manual of this CGC 400 as well as the Semac GC 500, and we'll just see briefly about the what the alarms they have mentioned and what troubleshooting is expected. So let us now see that one module which is like this is a Semac module, if we can see here. So this module is available on internet free of cost, so you can download it. Okay, there are many other versions is available, but this is easily available, so I downloaded this one only. So I will just show you, this is a features of the product. Like they have a digital switch input, like 5 inputs it can take, then analog resistive input. So here you can provide 3 different analog resistive input, like one is the oil pressure, coolant temperature and fuel level, but these all should be in the form of resistance. It doesn't have a capability to take 20 milliampere signal as a input, so this is a limitation. Similarly mains voltage input, then digital HSD, event logs, USB port. Okay, so these are the all basic things which is available as a feature. This is what here mentioned. Now we'll quickly go through the required page, right? So we can discuss in detail there. So let us now, I will just take you to the page number on 26. So here this alarms is mentioned. Now earlier in the supernova controller, def controller, we have seen that there is a fail class. Okay, similarly here is a alarm actions. So every controller has a different terminology, but more or less actions are same. Here we see it's a notification. Notification is means it will just tell you that okay, this has happened, but it will not take any actions. Similarly, if there is a warning, so in the warning there is a LED glow sound, beep sound also may come, but no any other actions will be taken. The third one is electrical trip. So on the electrical trip it will trip the load, it will remove the generator breaker. If it is on, it will trip the generator breaker, so at least alternator will be isolated, it will run on the no load condition, and then engine cooling timer begins, after which generator is stopped. So this is a trip basically. And shutdown, that means in this alarm action type, load is taken off from the genset and the genset is immediately stopped by skipping engine cooling time. So normally engine cooling time, what I said, that 60 seconds to 300 seconds depends on the type of engine. So but like a fault called low lubrication oil pressure so this is a very severe fault. We cannot even run engine after, even once this alarm is reported, even 5 second or 10 second running with this low oil is also dangerous for the engine life. So that's why immediately load has to be thrown off and engine has to be shut down. So these all fail class from 1 to 4 has to be selected based on the severity of the alarm. Okay, so now this one is the low oil pressure sensor and low oil pressure switch. So here also we already seen now that this oil pressure is coming from analog sensor, oil pressure is coming from digital switch. So we have a 2 different channels for the critical alarm. Similarly for fuel, similarly for temperatures, similarly for water level also. Then another alarm called overspeed, underspeed, under voltages, over voltages, under frequency, emergency stop, then battery charger fail, battery DG battery over voltage, DG battery under voltage, maintenance due. This is also a very important alarm, that as soon as we cross the hours, like we have learned in our section 2 that A check is a daily check, B check is every 250 hours completion, C check is roughly a 800 hours completion or 1 year, and D check is 1500 hours completion or 2 year. So once you program this, every 125 hours or 250 hours completion, it will give a notification that the next maintenance is due. So this is also a good feature that it can provide us a planning, advanced planning and preparation for the maintenance. Then also fail to stop alarm is also there, then fail to start. So basically when we operate the engine and DG set, our requirement is that it's a for the standby application. So that means when the primary power is failed, we run our DG sets. So DG's availability is very important. So those alarms which is not allowing to start the DG is always critical. Okay, fail to start and fail to stop both are critical, but in which as far as service availability is concerned, fail to start is more critical. So we have to see that if fail to start happened, what action is required. So now we will see that what troubleshooting is required. This is a manual designed by the controller manufacturer. So they will only give you that this is a fault code, this is an alarm, and what you have to check, but up to an extent only they will provide the idea. But as a operator, we are operating our machines, so we know our site environmental conditions better. So accordingly we have to predict and visualize that what could be the fault is. Even we are operating these DG sets remotely, but looking at the fault code and fault description, we can enable this troubleshooting also. So problem 1 is here mentioned, the controller does not power on. So if controller itself is not powered on, that means controller operates on the 12 volt of DC, and if controller is not powered on, controller will not start the DG set in a auto mode. So in that case, there is always a glass fuse is given in the DC circuit. We have to see the glass fuse, then we have to see the DG battery voltage also. So these two things is very important, that controller is itself is is a down. That means there is a most probable reason is the DG battery is not providing the sufficient voltage, and controller sometimes may get reboot, or if the fuse is blown, then we will not get any any input supply to the controller terminal. So this is what the action is. Now controller fails to crank start the engine. So we see that in a different controller, different kind of alarm comes, like crank failure comes, or fault code comes, and then start failure comes. But the requirement is when we see that engine is not able to crank. So cranking itself is a problem. So there could be no any problem like a fuel or so, that fuel is not there, that's why it's not cranking. Fuel could be not there, so it may crank, but it will not further start, it will again further stop because of non-availability of fuel. But here starting itself is a problem. That means starting circuit has to be checked properly. So in the starting circuit, which are the critical components that we have to think of? So always a DG battery and then self starter. These are the two critical components which are playing a significant role in a starting circuits. So if DG battery is down or is flat, it will not provide a sufficient torque and there will be a crank failure. Or if DG battery is okay, then dynamo, this self starter may have a problem and it is not rotating, and it is not able to further provide a torque to the engine. So this is the two basic hardware issue which may come in the event of crank failure or start failure alarm. Now we know that if crank failure is there for 3 times, then it doesn't allow further to crank because of the health of the DG battery, because it will continuously crank, then DG battery will further go into the deep discharge mode and it cannot be revived also. So just to protect our DG battery, it will only allow a three cranks, and after that it generates an alarm called a start failure. So other than DG battery and self starter, there is a configuration issue inside the controller that also we can verify. But if engine was running already before without any issue, then normally setting related issues are very minor. Roughly these are the only issues, like self starter connection is loose, DG battery connection is loose, DG battery is flat, or self starter winding is burnt. This could be the probable reason that it is not taking a proper crank. So this is what the person has to check. Similarly, there is an emergency stop alarms comes up even when the emergency stop is not passed. So if emergency stop button is not pressed, despite this there is an emergency stop is coming, so we have to check if the emergency stop switch is working okay. Also check its wiring and also in the configuration mode. So sometimes engine is continuously vibrating, and if that it is not properly grouted, or it is not, its installation has some issue because of some vibration also, the block NONC block of the emergency stop sometimes create such kind of trippings. So we have to see at all the wirings properly when we got the emergency stop as a alarm. So then, like a charger failed, alarm number 5. So if charger, like there is always a DG battery charger placed inside the DG set, which takes a power from grid and it converts into the 12 volt, and then it maintains some standard threshold voltage, float voltage, which is required to keep the DG battery always in a charge condition. So if that voltage, nominal voltage, we have to set during our configuration master file. So if we have selected a 13 voltage, and by chance if this battery charger is not producing this voltage, then we may get this alarm that there is a battery charger fail. So at least we immediately go and rectify. Now there is a command call fail to stop the engine. So when we get an alarm called fail to stop, so fail to stop is like that when DG has to stop and controller provides a command to stop the engine, but even after that if engine does not stop, that means that time this fail to stop alarm is coming. And we have to see, if we have seen in the section 2 that our stop solenoid valve cut off the supply from the fuel feed pump, and once fuel feed pump is feeding the fuel into the FIP, and from there it is going into the chamber. So if we restrict the fuel supply, if we restrict the fuel supply through stop solenoid valve, engine will stop. So that means even if we are giving a command, it is not operating. So there could be a problem that controller itself is not giving command, or if controller is giving command, then there is a stop relay which is not further extending the command, or there is a issue in the stop solenoid itself, that stop solenoid is not able to hold it up to a 10 second 5 second at the predefined time till the engine comes into the 1500 rpm to 0 rpm. So there is the three basic things has to be checked during a fail to stop alarm comes. Similarly, if there is a fail to start is coming, so as we see that fail to start will come, and if there is a issue called DG battery or starter, then along with a fail to start you will get a command called start failure or crank failure. But if crank failure and start failure alarm is not there, that means that starting issue is not there. Actually there is some other issues, like there is a emergency shutdown button has been pressed, or there is a LLOP is present, something other thing is there, because of that DG is failed to start. So all these alarm we have to see the understand the sequentially, so accordingly then we can take a fine and best quick judgment. So there are other set of alarms, but we will only go on the very critical alarm. This this is only helping us to ensure that DG should always up and running. So now we have I think learned all this critical alarm of the engine. Okay, and with this I think we can conclude here that in the event of critical alarms, what kind of troubleshooting is required. So I hope that this section is helpful in your daily life to operate the DG set in a trouble-free environment. Thank you.
Hello. I hope that you must have enjoyed today's session, and if you really feel that this is helpful and adding a value to your knowledge, then you can press a like button. Do share this knowledge with your friends and colleagues, and you can consider of subscribing my YouTube channel as well. You can connect it with me by pressing a notification button for all new upcoming tutorials. Stay tuned and happy learning.